Welcome to the tutorial for Probability 3 and 4. If you find this difficult or if you'd like a little bit of help before you start, then I can talk you through this exercise by working through it myself. And then when you have a go at it, the questions will be very similar, but the numbers will be different. You can't use a calculator for this exercise, but a pen and paper will be handy. So let's begin. So, Bag A and B contain a red counter and a blue counter and a green counter. Rebecca takes a counter at random from each bag. Complete the table of the list of all the different combinations. So it could be red and red. Well, the first one could still be red, but the second one could be blue. And the third one could be red and it could be green. And then if we do the same thing for starting with the blue one, if we just be very systematic, it could be blue then red, blue then blue then green. And the same thing starting with the green one. So it could be green and red, green and blue, and green and green. So they're all the different things that could happen. And by doing it systematically, we know we haven't missed any. So what's the probability that the counters are both the same color? So if we look at the possibility list, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 different things that could happen. And 1, 2, 3 of them, the red, red, the blue, blue, and the green, green, are the same. So 3 over 9, that simplifies to 1 over 3. And what is the probability that at least one counter is blue? So let's look through the list. We know we've got it over 9, but let's see how many of them contain at least one blue. 1, 2, 3, 4, 5. So it's going to be 5 over 9. Let's just check those. Great. On to the next one. So the pictogram shows the number of apples bought in a canteen over the last 60 days. 1 apple represents 2 days. Estimate the probability that at least 1 apple will be sold on Wednesday. So, if we realize that there were 2, 4, 6, 8, 10 days where they didn't sell any apples, that means that 50 days out of the 60 days, they sold at least 1 apple. That simplifies down to 5 over 6. That's our best guess. We don't know, but that is why it says estimate, and that is what we use for our estimate. Using this estimate on how many days would you expect at least 1 apple to be sold in the next 516 days. So that just means scaling this up. So we've got to realize that 5 out of every 6 days we will sell an apple. So how many is 5/6 of 516? And that's what our answer is going to be. So if we take 516, divide it by 6, and then times it by 5, then a little bit of written maths, we will get that it is 430 days we'd expect. Those. Excellent, we got it right. So the next one, sum of probabilities. So a bag contains red, yellow, blue, and green balls. The probability of picking them out is shown in the table. So we're using some algebra now. But what we've got to realize is that all probabilities, when you've got all options, add up to 1. So we know that this plus this plus this plus this, a plus 0.1 plus 2a plus a minus 0.1 equals 1 whole 1. So if we add those up, we get 1, 2, 3, 4, 5a. 5a is 1, which means that a has got to be 0.2 when we divide by 5. It's 150 balls in the bag. How many of them are red? Okay, so if there's 150 of them in the bag and 0.2 of them are red, then 0.2 of 150 is 30. So 30 we would expect to be red. Kevin says it is at least twice as likely that a red ball will be picked than a green ball. Is this true or false? So let's have a look. So this works out to be for red 0.2 and the green 0.1. So Yes, it is. It's true. It's true because 0.2 is twice 0.1. So let's check it. We've got them all right. Great. On to the last question. So this one's on tree diagrams. A library contains 100 fiction books and 900 non-fiction books. Whether a book is fiction or non-fiction, the probability that it has less than 100 pages is 0.2. Julian picks a book at random. We've got to complete the tree diagram. So 100 fiction and 900 non-fiction. So we want to put the probabilities on the branch. So 100 out of 1,000 is 0.1, and 900 out of 1,000 is 0.9. Whether the book is fiction or non-fiction, the probability is less than 100 pages is 0.2. So less than 100 pages, 0.2 for those. And because we know probabilities have to add up to 1, that means that more than 100 pages has to be 0.8. We're assuming nothing has exactly 100 pages here. What's the probability that Julian picks a fiction book with more than 100 pages? Well, the way we work through tree diagrams is you first think about how to get to a fiction book and then more than 100 pages, and you multiply them. So 0.1 times 0.8 is 0.08. What is the probability that Julian picks a non-fiction book with more than 100 pages? Well, it's going to go down this branch, 0.9 times 0.8. It's going to be 0.72. Let's just check these ones. And yes, we've got it all right. Well done. Excellent. So hopefully you can have a go at that now and do pretty well.